And again, because of the technical issues, our session chairman, Dr. C.K. Jain, will be joining in few minutes. So without wasting much time, I would request Mr. Anshul Mishra to start the presentation. Can you please introduce yourself, and then can you please start the presentation? You are on mute, sir. We will be making you as a presenter. You can share your screen 1 minute. Yeah, now you are a presenter, sir. You can share your screen.
So actually, just we are setting the presentation, Murli. We just take 1-2 minutes.
Yeah, no problem.
Is it visible?
Yeah, screen is visible, sir. Make it full screen and you can go ahead.
Is it visible?
Yeah, it is visible.
Is it visible, sir?
Yeah, visible, sir. You can make it full screen and you can start.
So, good afternoon, everyone. My name is Gopal Mishra, accompanying with Mr. C.C. Chaudhary, sir, and Mr. Anshul Mishra, sir, and guided by Mr. Lokesh Kumar Bhaiti, sir, Unit Head BDSPL. So, we are here for presenting energy efficiency initiatives that we have done in the last 3 years. So, in this presentation, the presentation consists of
Sir, can you make it full screen?
contents are plant overviews, our technical details of the plant, and whatever the achievement that we have done from the last 3 years, and the ENCON project that we have done in the last 3 years, and
Hello?
how we are utilizing our green energy, and what are the awards we got in the past 3 years.
Can you make
our
it?
carbon footprints.
Sorry. Hello. Can you make it full screen?
This is our carbon footprints. In 2020, we are at 702. But now at 2022, we are continuously on a reducing trend at 611, and our dream is to achieve at carbon negative -30. For this, we have signed.
Mr. Gopal, sorry to interrupt you. Can you make it full screen? You can see in the bottom near to the sizer. Yeah, next to that, before that. Below Dalmia, you can see the full screen mode. Make it full screen and then go ahead. Yeah, that one. Yeah, now it is perfect. Go ahead.
So these are our carbon footprint. We are on a continuously reducing trend. In the 2020, we are at 702, but in now 2022, we are at 611. So, and our dream is to achieve at -30. So for this, we have signed a MOU with FLS at Denmark in presence of our Prime Minister of India as well as Prime Minister of Denmark, and under the leadership of Mahendra Singh sir. So these are the plant view of our plant. We have a design capacity of 1.1 million ton per annum of clinker, and for cement it is 1.7 million ton per annum, and our product is only PPC, and we are the only integrated plant in Bihar state. So this is our technical details. Crusher 500 TPH designed by L&T, raw mill designed by KSD with 200 TPH, cold mill designed by Loche with 21 TPH, and our preheater with having 2400 TPD, and cooler is also designed by the KSD. And cement mill we have designed from CPW, and its capacity is 140 TPH. So these are our achievements that we have done in the last 3 years. Like in raw mill, in 2019-20 we were at 107 TPH, but now we have improved our production rate from 107 to 192, and our power is also reduced from 22 to 13.98. Total 8.67 kilowatt per ton of saving we have done after acquiring this plant. For this, we have done some of the modification like upgradation of raw mill dynamic separator. From second generation to we have changed it with a new generation separator with the help of KSD. We have also modified our roller press and also installed their choke feeding system with roll cogs, and we have installed VFD in raw mill fans. We have also optimized our start and stop interlock as well as purging systems, and we have also modified our ducts to reduce pressure drops in raw mill section. We have reduced our false air from 20 to 12% right now in the raw mill section. This is the cold mill. We have improved our TPH from 9.5 to
Mr.
13.5.
Gopal?
Our power is also optimized from 85 to 61 in 2021-22. We have total reduced our specific power reduction from reduced up to 24.1 kilowatt per ton of material. For this, we have taken the help from Roche, and we have upgraded our cold mill classifier, table liners, arbor ring, nozzle ring, and we have also replaced our rollers and some of the LRS driven motor has been replaced with VFD, and also optimize our interlocks, and purging system is also optimized. These are our kiln section, and these are our kiln section. We have earlier we have a kiln of TPD 1600. We have modified 1600 TPD, and we have also reduced our power from 41 to 19.78. Total 20.86 kilowatt per ton of saving we have achieved from the past 3 years, and we have also reduced our specific heat consumption to 166 kilocalories. For this, we have done some of the modification, like we have replaced our top cyclone with high efficiency cyclone from 92% efficiency to 96% efficiency of cyclone. We have replaced our preheater fan with high efficiency, cooler fan with high efficiency, and as well as VFD installed in that. And cooler static grade we have modified with ICANN first and second grade from conventional grade cooler. We have also increased our RPM of kiln RPM from 3 to 5.5 by replacement of gearbox. Plus, we have replaced our inlet and outlet seal, changed with graphite laminar seal. We have changed our pre-calciner from SLC to ILC with increased residence time from 2.8 to 7 seconds. So these are the ENCON project that we have done from the past 3 years. We have these are the power saving with every projects, like preheater fan replacement. We got the saving 3.3 kilowatts. Cooler fan replaced with high efficiency and VFD driven. We got the saving 2 kilowatts. Top cyclones we have changed, so we got the saving of 0.6 kilowatt. And inlet and outlet seal replaced with laminar seal, we got the saving of 0.5. Our enhanced clinker production from 1650 to 2850, we got the saving from this 7 kilowatt per ton of clinker. Our raw mill fan we have optimized. We got saving 1.7 kilowatt per ton of raw mill, and our raw mill circuit we have optimized. We got the saving 3.2 kilowatt from that, and our cold mill classifier, rulers, tables replacement has been done. We got a saving from this is 10.1 kilowatt per ton. And these are the energy saving that specific heat we have saved from this project. Like we have replaced the top cyclones, inlet and outlet seals, false air has been arrested. Earlier the false air was 40%, but now it is at 6%. And our static grade, cooler static grade also replaced with ICANN. So our flow is improved in that. So we got a saving in that 62 kilocalorie per kg. So these are the main Encore project that we have done. Now coming to our green energy initiatives. There are many challenges we have faced for installation of this green energy and for improving the TSR in green energy. So this is the circuit of greenfield. First, there is a shredder, as you can see in the left corner, and where we dump our greenfield material into shredder hopper. Then the cutting operation taking place, and then this where reject material is again sent to the shredder, and the product is sent to the extractor. There is a wave feeder installed in the below the extractor for giving a set point to the CCR operator, so that we manage the feed rate of the AFR material. These are the flow sheet of greenfield system. This is the shredder which is used for cutting, and then there is a screen which is used for screening the material, and there is the extractor which is used for extraction. This is our AFR system, and this is our shed that is installed in greenfield system. There is a EOT crane we have made for reducing the diesel consumption. Earlier we are using JCB for feeding AFR. So through that we are consuming 200 liters of diesel. But later on we have installed EOT crane. With this right now we are just consuming 50 liters of diesel. So these are the materials that we are using. Multi-layer plastic with CV of 4500, FMCG CV of 3000, RDF, Bata waste is around 3000 CV, Flash mud 3000 CV, organic solid residue 3000 CV, MSW 2000, DBT liquid 2000 CV. So these are the AFR consumption of May, which is by far the highest TSR we have made. These are the maximum we have utilized PP waste and flash mud and paper waste for achieving this TSR target. Right now we are at 20%, but from the last 3 days we are getting 27%. So we are targeting toward 30% in the next financial year, till next financial year. So these are our TSR trend. We have made this AFR system in December. So through December, the TSR rating is continuously increasing from 9, 12, 18, 16, 20, and most probably we will reach up to July. We will reach up to 25. So these are our WHRS. Successfully erection has been done in the May month. Just in the last month, we have done this. We have generated we are generating 4.5 megawatt from this. AQC PH boiler taken in operation just 24 May, but AQC was in operation from the 1st May. So we are generating 1.65 megawatt power from this, and PH boiler just last day we have achieved 2 megawatt. Total 3.65 megawatt we are generating from WHRS. This is erection of floating solar panel with 3.7 megawatt is in progress. We have deal with photovoltaics company, Purushottam. Here we are installing their solar panel for generating 3.7. This work is in progress. These are our waste utilization. We are utilizing completely petcoke up to 100%, and we are utilizing fly ash 35%. And whatever the waste generated like cotton waste, waste bags, grease are also fired in the kiln. And as you know that our TSR is reaching toward 20% at the waste utilization. These are the some beautification work that we have done in silos. Raw mill silos also done, and in clinker silo. This picture is for clinker silo. This is just a beautification work that we have done. So these are the award and recognition we got for the mineral conservations from Indian Bureau of Mines. Thank you, sir. These are the visions and goals, values of our project. Thank you, sir. Any question, please?
Yeah, thank you, Mr. Gopal Mishra. Sir, actually, once again, good afternoon to all the participants and the speakers. So we have Dr. C.K. Jain have joined us, our session chairman. I am on behalf of CII and all the speakers, I welcome Dr. C.K. Jain for this session. Sorry for the inconvenience we had because of the technical glitch in joining. So Dr. C.K. Jain is the most appropriate person for heading this session on sustainable production. He has more than 5 decades of cement industry experience. He joined cement plant and then he grow with that, he grown with that, and then he has executed many projects. He has excellence in operation. He has taken the plant and the group to high level in sustainability. And now after his with his rich experience, he is adding value by becoming a member in the jury panel of Energy Award, National Energy Award CII member panel, as well as he is adding value to the society by becoming an assessor in the Greenco panel. Over to you, sir. Over to Dr. C.K. Jain, sir.
Good afternoon, everybody.
Good afternoon, sir.
I'm sorry that I joined a little late on this. I first of all, I thank CII for giving me opportunity to chair this session, and I also congratulate CII for organizing and hosting this Green Cementech 18th Green Cementech with the most appropriate theme, that is we say net zero carbon future, because you see that in coming days the net zero will be carbon, and for that so many technological innovations will be coming. And to achieve this net zero, definitely the technological breakthroughs are required. But for our theme, and it is sustainability in the production, that is most important in present time, because it is for us, it is easily available. We know what is to be done, and lot of informations are available through CII and through different plants. And we can concentrate on energy efficiencies, we can concentrate on clinker factor reduction, and many more things are available. And I feel the 4 presentations which are fixed for this particular session will give a lot of information to all the participants, and they will be able to do much more better in their plants. The presentations scheduled in this is energy efficiency initiative from Dalmia, reduction in clinker factor already completed, actually first one, reduction in clinker factor by Manjunatha R, and a science-based target for GSG emission by Mr. Misal Bhavasar, and energy initiative by JK Cements. I'm sure this will help all the participants to do a lot of more things by understanding from each other. I will not take much time. I think Mr. Murli will help me. Who is the next schedule presentation?
Yes, sir. Actually, we have to request Dr. Manjunatha to present about the clinker factor.
Murli,
Yeah.
can I add
sir,
1 or 2 few words?
With the permission from chairman, sir. I think we
Yeah,
can.
Mr.
Yes.
Jain sir.
Mr. Lokesh.
Yes, sir. Namaskar, sir. I am Lokesh by the unit at Banjari unit. The beauty of this plant, this plant is very, very old, sir, 1939 made. But right now, this plant is running excellent condition in terms of power, in terms of heat. Last week, we have achieved 27-28% of green fuel as a FR material. And at present, we have 4.5 megawatt WHRS. And very soon, in the next couple of months, we commission solar power. So at that time, our power, we are self-sufficient for power point of view. This is the beauty of old plant. But right now, this plant is, you can't imagine, this is old. Right now, this plant is very, very good in terms of heat and power, and compared to our latest one of the unit. This is the beauty of this one. That's all, sir. Thank you very much, sir.
I fully agree with you. It's very difficult in any old plant to make so many changes, and it's really something wonderful you have achieved. Actually, it's really, I have seen the numbers. Numbers are fantastic, and almost in all the fields you have done a wonderful job, and all other plants definitely can learn and can definitely implement many more ideas, many ideas taken from you in their plants. and particularly the old plants. Many people feel that old plant can, because of the technological problem and other things, they cannot do anything. You have shown a path to them. Thank you.
Thank you, Chairman. Dr. Manjunath, can you please share your screen and then start? Thank you.
Next, I think it is reduction in clinker factor.
Yes, sir.
Doctor, I request Dr. Manjunath R to start his presentation.
Thank you, sir. Thank you. Okay, it's my great pleasure to present at CAI. It is a very interesting and important topic. The seminar is being organized mainly to decarbonize the cement industry on various ways. JSW, as a part of its sustainable strategy, we are mainly working on reducing the clinker factor in cement production. The very reason is that we are one of the largest producer of steel. So we derive slag out of steel manufacturing. Then also we are one of the largest producer of energy. And we have a couple of thermal plants close to 4,000 watt. And now we are moving towards more sustainable energy through wind and solar. So with these two important core industries producing a lot of byproducts, our cement plant started way back in 2008. So since beginning of the manufacturing process of cement, JSW has taken it forward to make it the most energy efficient and also most sustainable cement manufacturing in the world. I would like to share it through my presentations. As a group, JSW is $14 billion group having presence in India, USA and Italy and Fujairah, Middle East, to its various operations in steel and cement mainly. And we are one of the largest producer of steel and also cement. We are growing from 0 to 14 million tons capacity currently, and we will be 21 million ton capacity by 2023 and going to be 30 million ton capacity very soon. The success story of JSW is establishing energy efficient, eco-friendly cement plants across India, and we are spreading very fast west, south and east. Our dominance is there, our presence is there, and very soon we are starting our operations in Rajasthan, Gujarat and many other parts. So how JSW is progressing is that the testament is the products we are manufacturing. 99% of our all products are eco-friendly products using our byproducts like slag and fly ash and other ingredients. We are making eco-friendly, starting from cement manufacturing to GGBS manufacturing to ready-mix concrete manufacturing and CC product manufacturing. JSW has not left even a single product untouched, moving towards sustainability and increasing the durability performance of the concrete, which is second most consumed product on this planet only after water. So we know how the world is changing. Changing is very fast. Rapid urbanization, huge population growth, phenomenal. 9.2 billion population is going to inhabit the planet by 2050, and India will be having close to 1.6 billion population by 2040. So India is the second largest producer of steel and cement together. And also 40 to 50% of the population of India is moving towards urbanization. So we are creating more and more in concrete jungle. On account of that, India is not lagging behind. It is the third largest emitter of carbon dioxide emissions globally. China 27%, America 11% and India 6.6%. So considering our economic growth, India is a superpower now in terms of economic growth, development, fastest growing economy in the world. The kind of GDP growth they are forecasting is 6 to 7%. With that, the mega infrastructure projects, metros, expressways, ports, coastal Bharatmala, Sagarmala projects, we are going to consume lot of raw materials. Lot of materials in terms of cement, steel, and also the aggregates. So how we can make it sustainable? See, we have to adhere to the triple bottom line of sustainability. we should first of all look at the social economic benefit. Whatever the innovations R&D we do, it should be towards, it should be economical, it should be having larger social benefit, and also without affecting the environment. See, why we are considering all these three a triple bottom line for sustainability is mainly because of the we have to have a local manufacturing with global technology and reducing the carbon footprint each and every aspect of our product innovation as well as manufacturing, consuming lower energy in each and every manufacturing process, and prolonged life, giving durability to the structures, durability to the concrete and construction. So how we can do that? We know the world is changing, evolving fast, and we construction industry consumes 40% of the world energy, emit 30% of the global emissions, create 10% of the global dust. We creating concrete jungles. We are creating biodiversity change, ecosystem change because a lot of mining is involved, and also our per capita consumption of cement is very less compared to the global standards. And we know the cement manufacturing is not an eco-friendly activity. It consumes 1.5 tons of limestone, consumes 0.22 to 0.25 tons of coal for every tons electricity. Consumption is there, and also we have emissions ranging from 800 kg to 1 ton for every ton of clinker production. And apart from that, coupled with these emissions, we are it's not a sustainable activity. We have a lot of emissions, water pollution, air pollution, releasing so many chemicals to the atmosphere, and uh, cement industry accounts for 5% of the total carbon dioxide emissions. So we know how the emissions come from. In the cement manufacturing, decarbonizing the limestone is the biggest emitter. Okay, so almost calcination process, 475 kgs per every ton of calcination process, and also using fossil fuel like coal, electric power, further 319 kgs emissions. So it's a major chunk of emissions are going to come from the cement manufacturing. But without cement, we cannot make concrete. Okay. Even though there are a lot of technologies evolved, like geopolymer technology, which doesn't use cement, but uses byproduct like fly ash and slag. Uh, but we have to accept the fact that emissions are going to be there. So the whole world is now moving towards sustainability, net zero carbon dioxide emissions reduction. But India continuously expanding the cement production process. So currently the installed capacity about 540 million tons and going to be 700 to 800 million tons by next by the decade. But so the industry is emitting huge emissions. Steel and iron 8%, cement 7%, together put together about 13 to 14%. We know the emissions, total emissions 2.52 gigatons. So this is creating lot of havoc. We are seeing heavy rains in the May month in Bangalore and other cities and all. It was not there. So pre-monsoon showers are heavy. So because of all the ocean temperature rising, atmospheric change, cyclone effect, urban heat island effect, these are all causing the change in the environment. And also global temperature is rising phenomenally, and many island nations will be submerged in the next 10 years time. So we cannot say maybe 50 to 60 major cities which are along the coastline will be submerged in water because of the rise in the water level. So what we can do, being a company, we have taken all the cares in terms of manufacturing, in terms of clinker reduction, in terms of low clinker cement manufacturing. The global average is about 608 kg per ton. National Indian average is 560, but JSW is able to achieve 215 kgs with its innovative approach, innovative process and technologies. So how JSW is achieving, I would like to present one by one. So we are looking at using our industry byproducts, our own group companies byproducts, uh, slag and also as well as fly ash and other products using alternative fuel technology, new cement products, low limestone based calcined clay cement, geopolymer concrete technology, and also using renewable energy, waste heat recovery systems, biomass energy. These are the various technologies we have deployed to become the world leading energy efficient cement company. The process what we have adopted is alternative cementitious materials using thermal power plant and steel intensity byproducts, carbon capture, we are working on that, and carbon usage, and also working on agro cement. These are the various systems JSW is adopting one by one. So why the global cement production is continue to grow and we need to continually reduce. So we being the champion of sustainability, we have to continuously evolve ourselves to reduce the carbon footprint. So case study at JSW, I would like to say, way back in 2008, we started with 0.6 million tons, already 14 million tons, having footprint across length and breadth of the country except North India. And all our products are green, as I've already told you, because of our ingenious process of inventing new products, green products. So this is the graph how our GGBS production, which is the carbon footprint is only 60 kg per ton of every GGBS production. Okay, so combination of OPC cement and GGBS supplying to major projects, we are able to reduce the carbon footprint phenomenally. Annual reduction average is about 13%. This is the graph which shows that world average and also JSW where we stand, and also continuously we are evolving. Not only we are standing that we have already achieved the success, it's not that. We are continuously expanding clinker production. So there also it comes that how we can utilize various byproduct from other sources to make the cement production energy efficient. So clinker factor reduction we have done phenomenally. We use almost 60% of GGBS in slag cement manufacturing. Use 35% of fly ash for fly ash cement manufacturing. Also, we are the pioneers to launch the composite cement which uses both fly ash and slag in making. This is our story, how we are efficiently able to reduce the carbon footprint. And also, coming to the blended cement, advantages are many. Even today in India, OPC cement is being sold in the retail market. It should be stopped immediately. And all the concrete should move towards ready-mix concrete. Because OPC selling still in South India, it's phenomenally high. It should be reduced. All the cement companies should take a pledge not to sell OPC cement in the retail segment, the IHB segment. Because all the RMC plants were there, about more than 7,000 RMC plants across length and breadth of the country. They are using cementitious material like fly ash and GGBS to make concrete. They go up to 60% blending with GGBS, 35% with fly ash. So blended cement should be used and continuously used in all the IHB segment. Because many advantages are very good strength development, lesser leaching, lesser reinforcement corrosion, and long-term strength. So, and also the performance of the blended cement, the PSC, the composite cement, and the PPC is much superior compared to the OPC cement in terms of long-term strength, alkali silica reaction, chloride-induced corrosion, carbonation. These are the various factors. So overall, we are looking at circular economy using the waste industry byproduct, waste heat recovery system, municipality waste as a biofuel, and converting all this product and making cement production globally eco-friendly and also with a lesser clinker application. So way forward is in India, as we continuously growing in terms of housing, infrastructure growth, expressways, corridors, we continuously use cement. So we should go with the blended cements. When you are having a RMC patching plant, go with a blend of GGBS or fly ash or ultrafine materials to reduce the clinker factor. This is what we would like to advocate. Apart from at the plant level, waste heat recovery systems, alternative fuel technology, hydrogen fuel, and also carbon capture and carbon usage. These are the various technologies to be adopted. And using GGBS, we have phenomenally successfully done across India, various major projects. So sustainable concrete is nothing but using optimized material in the mixed design, using recycled byproduct like M sand, slag sand, improved and optimization, reducing the structural thickness of the members by going for high grade, high performance concretes, innovation in process technology and materials. These are the hallmarks of moving towards sustainable concrete, because concrete is the ultimate product. Cement is a byproduct of the concrete. So how we can make it? Mineral admixtures, high range chemical admixtures, alternative to river sand, alternative to coarse aggregates, nanomaterials, geopolymer technology, and also non-conventional construction like bamboo construction, aluminium, plastic, and polymer. These are the technologies. And also our code permits usage of GGBS as well as fly ash in concrete making, usage of blended cement in concrete making. It's all allowed, and we can design starting from M5 grade concrete to M200 grade concrete with using the mineral admixtures and also high range chemical admixtures. These are the various alternative materials available in the industry, which can be blended for making blended cement as well as blended concrete. So by supplying GGBS, JSW has achieved a phenomenal success. We are able to save 9 million trees because we are able to reduce the carbon footprint by 9 million tons in last 6 years. Limestone reduction 14.5 million tons. Okay, landfill dumps saved 14.82 million tons and 80.91 million cubic meter of concrete we have done with GGBS. This is a success story as a company to reduce the global carbon footprint by saving not only energy, also by reducing the carbon footprint. And because of that, we have got many certifications and awards. CII has approved all our products in the green certification zone, and many awards. Golden Peacock Eco Innovation Award we have got. This is our leadership, and many projects. Name the Rama Janmabhoomi Tirtha Kshetra, where the designed the foundation for infinity, not for any years, 100 years or 1000 years. It's for infinity. There they have used GGBS, taking all the way from our Dolvi plant. Many projects: Bangalore Metro, Chennai Metro, Nagpur Metro, Pune Metro, Mumbai Metro. They are all using GGBS and slag cement for concrete making. Even underground constructions, effectively they are using all our products. These are the many structures we have, and many my one former technology, high-rise buildings, all they are going with eco-friendly technology. This is a very good sign to see. Even the concrete roads, this is a nice road which are being done at Bangalore. And we have launched recently ready-mix plants across many places, and everywhere we are advocating green concrete products. So these are the major clients we have, major government projects, major infrastructure companies. They are utilizing our product in each and every application, and major RMC companies, they are using this product. So I would like to conclude my presentation today is that the move towards net zero in cement manufacturing is that developing low carbon clinkers using technology, and also shift to use blended cement, composite cements, then geopolymer concrete technology, and also using SCMs like ultrafine materials, using GGBS, using fly ash in the ready-mix plants and infrastructure projects. So with that, I would like to conclude my presentation. Only one word I would like to say: we in India, being a pioneer in sustainability initiative, JSW would like to contribute a lot to the world, not only in India, to the world, and be the leaders in sustainability and maintain the position of world #1 eco-friendly cement company forever. Thank you.
Congratulations, Mr. Manjunatha. You have presented very nicely. Your presentation was having a very good content. I would like to say that you are really a sustainability champion because of certain good factors with your company, better planning, that you are having a steel plant and then you have shifted to cement plant. And you have a lot of your waste material, which normally called waste, slag, etc. It's not a waste now, it's a raw material nowadays. And you are able to use them effectively by putting various cement plants, and you are expanding. This is good, and you have achieved quite a good numbers, and there are many more companies can do similar way. Definitely, we must be ready for new norms maybe coming up by the government of India of use of fly ash to 40%, lime cement. Because I remember 3 years back, all the research paper were submitted to the government, and it was recommended that this can be allowed in India. Composite have already come actually. Of course, market to accept more composite cement. But for you, now you have a slag cement and PPC combined together, slag, everything. That's very good. Your all product are green, particularly green certified. I would request all the participant that each company should go for green co certification and green product certification. It is not. It's not that some logo will come that it is certified, but this certification makes your company green, and you will be working wonderfully in all the fields of reducing the raw material, reducing the energy, reducing the water, everything, all the field. When you do, then only you get these certifications. So therefore, it will your company is a wonderful example of sustainability, and many more company can learn from it. You are definitely a leader, and you are going to become leader because you are totally expanding in total country. It's a good thing. Keep doing it. And there are many more new things can be done, because there are certain things you have done is you are having that advantage with you. Like slag is available. Many people don't have slag, and of course you are selling, but it's a huge cost to them. For you, it is not that cost. So therefore, it is much better for you to promote more and more this type of cement. And I am sure that CII must be taking up with government of India. Particularly, you said that, you rightly said rather, OPC should be stopped. I would like to say that at least 53 must be stopped immediately. Because still, you see, if you go to the construction industry, there is a clear mindset that slag cement, PPC cement, they can be used for masonry and other things. For beams, columns, and all those things, they still feel that only 53 is the better cement. It is a misconception actually. And if I know correctly, many countries in Europe have banned 53. So these are the initiative required. I think Mr. Murli will take up these issues with the government of India. Now this government is a very good government, listening to many things, particularly new ideas. So therefore, these things should come from regulation. Then only things will change drastically. In our country, unfortunately, things doesn't change easily. So therefore, regulations are required. Excellent presentation. Thank you very much.
Thank you, sir. I don't know what I request, sir, from this forum. The bagged cement OPC should be completely stopped.
Yes.
Only cement OPC should be given in bulkers for the projects
Bulk
and
bulk
plants.
You are 100% right. Actually speaking, if you use a bag particularly, then what happens? This means you will be mixing through a mason and other things. Then that it will not give a proper strength. It will not be good. It is always RMC is the best options. Of course, it is taking up, but in smaller towns and other things, it will take some more time actually.
Yes, sir. Yes. Thank you, sir. Thank you, sir. Thank you.
Yeah. Next, science-based target for GSG emission, Mr. Vishal Bhava, sir.
Good afternoon, everyone. I'll just share my screen. You can confirm me. Just confirm me if you're able to see the presentation.
Yes, sir, I will do that.
Only are you able to see?
No, sir, yet to.
I've shared from my side. I don't know.
Can you unshare and share again, sir?
Let me do. Now is it come?
Yeah, sir, it's coming. Yeah, perfect, sir.
All right. So good afternoon, everyone. My presentation today, I'll try to touch upon science-based target and how as Ultratech Cement, we have approached the concept of setting science-based targets. So it's more of maybe the process and what kind of challenges we have faced as an organization. That's what I'll try to share as part of this presentation. Before I delve into the science-based target presentation, just in terms of broad sustainability strategy, what Ultratech Cement is focusing, and all of this are predominantly from environment side, but we are also focusing on social as well as governance side. But when we look at from environment performance, like 4 key themes we are pursuing. The first one being obviously related to climate and carbon. And there we are adopting a lot of new technologies for carbon reduction. We are trying to look at completely looking at new processes. How do we approach the manufacturing of cement? We are also trying to maximize the share of green energy, trying to also use tools like internal carbon price. So that's what we are trying to do from a carbon or climate point of view. Water again, even though cement is not a water intensive sector, but sheer volume of manufacturing what we do as well as the captive power generation, we do consume water as business, but we try to pursue our long-term strategy in water from the water positivity concept, like all other cement companies over here, and things on water recycling, reuse, trying to maximize maybe the rainwater harvesting, and also adopting the concept of zero liquid discharge. Circular economy, I think previous speakers have also touched upon, and as Ultratech being the largest cement manufacturing company in India as well as concrete company, we consume to the tune of more than 20 million tons of waste every year. So it's one of the biggest consumption of industrial waste, both in form of alternative materials as well as fuel. And lastly, biodiversity, because uh, the way in the nature of our operations, we have impact and interlinkages to biodiversity. So that also features as one of the material topic for us. And for all of our sites, we are doing biodiversity assessments. And I mean, all of our integrated sites, we are doing our biodiversity assessments and also having a management plan in place. And as business, we are committed to this no net loss. While we are doing all of this from sustainability and ESG point of view, we also try to see where do we stack up globally. So as Ultratech, we are 7th in the DJSI ranking, and we are striving to be among the top 5 companies on the sustainability ranking at DJSI. Now, that was just one slide on sustainability strategy, but now most of my presentation will be hovering around science-based target. So just for the benefit of everyone, science-based target as a concept came.
Mr. Vishal,
yes.
Mr. Vishal, sorry to interrupt. Actually, there is a window open which is partly hiding the presentation. Can you minimize that? If you click on that, it will go away.
This one?
Yeah. Yeah, now it is.
Okay.
Now it is
Thank
fine.
you. Thank you, Murli. Yeah. So science-based target, for the benefit of everyone, it came into picture after Paris Agreement was signed up, and because in Paris Agreement, countries agreed that all of the countries collectively will work towards below 2 degree and also strive for below 1.5 degree. Now, to be within that 1.5 degree scenario, there is only so much of carbon emission which can happen from now till 2030 and eventually till 2050, when everybody has to move towards net zero. So there is only a certain quantity of carbon which can go into the atmosphere, and that was the reason why this science-based target setting process got introduced. And it came into picture before Paris Agreement, but I think the action and uptake started happening after the Paris Agreement. But as any organization, if you want to take science-based target, then there are 4 broad steps for any organization. First is that you commit to science-based target, and how you can commit is just that you write a letter to them that as a company or as a business you are committed to sign up for science-based target. The second step is develop. Under develop, you have to do if you don't have your carbon footprint, then you have to do the inventorization of the within 3 scope 1, 2, and 3, and then depending on what kind of method. So science-based target website has like detailed methodology of target setting. So there are methods for sectors which does not have so much of emissions, then we are supposed to take absolute reduction or absolute contraction. For sector heavy or hard to abate sectors like cement, steel, power, chemicals, there is a sectoral decarbonization methodology to set your target. So this develop stage is where you do your GHG inventorization, and then science-based target has an Excel which will ask you, okay, what is your production level in your base year? What will be your production level in next 15 years? So that kind of planning you need to give. What is your baseline scope 1 and scope 2 emission in your base year, and what will be your likely emissions in basically that will come out from that tool. So this develop stage is where you do all of this. Then third stage, which is submit, where you submit your data, your information to the science-based target team. And then there are like several rounds of discussion where there may be queries and justifications which you will have to provide. And once those targets are reviewed at the submit stage, last stage is when you can publicly announce your target. So when you do a commit stage at stage 1, you will say that I am in a process of setting my science-based target. And once your validation is happened, at the 4th stage is when you can publicly announce the science-based target. In our journey or road towards science-based target, for us, we started.
Mr. Vishal, sorry
Yes.
again. At the top title portion also there is a hiding is happening.
Yeah, there is a.
I'm not familiar with this.
You can just click on that.
Yeah, is it gone now?
Yeah, now it is okay.
Yeah, now it's okay.
Thank you.
Thank you.
In the for us as a road to science-based target validation, we started this process somewhere in 2020 June, and we first had a management buy-in. So we had to convince our management that why science-based target is required, because a lot of investors were asking us that you as an organization need to have a science-based target for yourself. And then we used a tool and also presented what kind of reduction targets we'll have to take up after we undergo the whole process of science-based target. The second stage, as we submitted our commitment to them in July 2020. Then there was one option for us where CDP and WWF were running one SBTi incubator. So what it helped us is this team of CDP India supported us in the whole journey. So once we became part of this SBTi incubator in 2020, they helped us in this whole target setting process. So we submitted all of our data to them. This has again come up. So August till August to November 2020, we did all of this data collection, validation, simulation, and then finally between December 20 to January 2021, we had 3 rounds of interaction with the SBTi team, and we satisfactorily provided our input, and our targets were validated by February 2021. And in March 2021 is when we made a formal announcement publicly that our science-based targets are validated. In our case, our targets currently are validated for below 2 degree scenario. And why that is because for cement sector, currently there is no tool for below 1.5 degree. It is under preparation. Actually, it was there as under public consultation for last 2 months. And next month, which is in June, they are going to publish this net zero standard, and where this tool of below 1.5 degree will also be available. And that's when cement companies can approach science-based target and get their target aligned to below 1.5 degree scenario. Now, what are the kind of challenges we faced while we had undergone this whole target setting process under science-based target? So I try to broadly classify these challenges into two buckets. First one is technical. In the previous slide, I explained that there are multiple methods in which a company can set their target. So there is a method which is absolute contraction, which tries to say that in next, let's say 2020 to 2030, you need to reduce it by whatever 3 or 4% so that you move towards net zero by 2050. Those are for sectors where, let's say, technology is in horizon, where mostly it is power consumption related transition which needs to happen. For those sectors, absolute contraction is the right method. But for sectors like us, which is cement, the technology is still not available, right? We know that broad areas, but the technology has not evolved. So for our sectors, there is some leeway in terms of target, and we need to use the sectoral decarbonization route. And last is this economic intensity contraction, which is more for services companies. So this is one level of complexity which companies will have to face, is what kind of method I choose. The second is the tool which companies need to use for target setting. There are versions and there are various versions which gets upgraded. So you need to be well versed with which tool or which version is applicable in your case, and then use the right version for your target setting process. The third point in technical is the input data for tool. So you need to understand, let's say, what boundary you need to select when you give your scope 1 emissions, scope 2 emissions, and then whether what kind of base year you will choose. So those kind of input data you need, and we struggled actually, and that's why I'm captured these as challenges. And the last point in technical is what should be your base year and your target. So for base year, you are allowed to go about 2 or 3 years behind. So if you're doing it now, then maybe you can take a base year till 2018 or 19. And for SBT target setting, forward-looking target setting, you can take target for maybe end of 5 years or 15 years. So then, depending upon your comfort, you can choose your base year as well as your target year selection. So those are the things which you will grapple when you do the science-based target setting. And then when I look at non-technical challenges which we face, the first hurdle for us was management buy-in, where we had to convince the management that this kind of we need to undergo this whole process of target setting. That was one of the key challenge which we faced. The second point was this lack of direct interaction. So when you do this target setting process, there is no way that you can talk to the science-based target team. It is just a mail-based exchange which will happen. So you will struggle to maybe interact with them. So that is one of the challenge which we faced. The third one is when you have to make an announcement. So after your targets are validated, when you are going towards the announcement, you need to align your own communication team with their communication team so that a more synergistic announcement could be worked out. And lastly, timeline. I think the whole SBTI team, there is so much of requests going in from multiple countries and companies that there is a lot of backlog, and it is leading to almost like a longer timeline. So these are the kind of challenges which we faced as a company in the whole target setting process. Now, challenges are one part, but as a whole process, when I look at what are the kind of learnings we had as an organization. So one learning for us is when we had not initiated this whole exercise, it actually looked very complex for us. But believe me, once someone from your team or the whole team takes part in this whole process, I think it is getting more simpler day by day, because you have many people who have understood the process, and maybe once your team also understands the requirement of science-based target, it becomes more of a learning process for each one who becomes part of this whole target setting process. The second one was this GCCA. So GCCA, which is Global Cement and Concrete Association, or we are making GRI disclosure, or we are making CDP, which is Carbon Disclosure Project. All of these disclosures are becoming simpler. So once you have undergone this process, you will be able to respond to multiple of these disclosures easily. That was the second learning for us as part of this process. The third one is because so many stakeholders expect you as a cement company to set targets based on science, that once your targets are validated, all of the stakeholder has like a higher level of confidence in you as a company. So post validation, actually a lot of investors were also convinced, and in our case, if you have also heard that after science-based target were validated, just after that we also went to market and raised sustainability linked bonds. So that there again, the investors who subscribed to the bonds had a lot of confidence in the whole process because the targets were set based on science-based SBTi requirements. And lastly, you do this SBTi related targets, it helps you convince as an organization that you are getting closer to the net zero. Like in the previous session also, the JSW colleagues spoke about net zero, Dalmia colleague also spoke about net zero, and the session chair also spoke about net zero. So a company who undergoes the science-based target setting process, you start to believe that you are getting towards that goal towards net zero. So broadly, these are the kind of learnings which we had as part of the whole science-based target setting process. Now we had our target set, we had certain kind of challenges, learnings, all of that. What are we doing as a company to be below this 2-degree scenario, to keep our business aligned to this below 2-degree, and whenever the 1.5 degrees tool is available, we'll also approach to get ourselves validated under below 1.5 degree tool. But yes, broadly our strategy for decarbonization is like, first thing is we try to use most of the decision making tool. What I mean by that is, so internal carbon price is one good decision making tool which is available for companies to reflect on their performance of decarbonization, and then depending upon the level of target you need to achieve as a business, you will recalibrate your internal carbon price, and that helps in terms of moving the decision towards more low carbon technology and process, which as Ultratech we have started doing. The second one is we also adopted this task force for climate related financial disclosure framework last financial year, and we have made the full disclosures for both set of physical and transition risk for our business. So we are using this kind of decision making tools for us to accelerate decarbonization. The second area is product mix. So I'll not speak a lot because previous speakers have also alluded to this point, but yes, our goal is also to move towards low clinker cement as much as possible. And we also try to reduce resource consumption at end use. So we want to work with our value chain partners and see that the story doesn't end just on our operational boundary, but we are also able to get other stakeholders in this journey of net zero, because eventually it is the whole world who has to move toward net zero, and just not you as a company who has to move towards net zero. The third one is technology levers. So as all the cement companies are doing, we are maximizing energy efficiency. We are investing a lot in alternative fuels, alternative materials. We are also investing into clean energy. And we are also looking at emerging technologies like carbon capture, storage, energy storage. Those are the things which we are working on currently. And lastly, we also sign up to some external partnerships. So we have committed to EP100, where we said that we'll double our energy productivity in next 25 years from the base year of 2010. We have also signed up to RE100. We have said that by 2050 or earlier, we'll have 100% of our electricity coming from renewable sources. So broadly, our targets in terms of quantitative numbers, our science-based target is for scope 1, we'll reduce 27% of our scope 1 intensity by 2032 from the base year of 2017. And when you look at the scope 2 emission, then we said we'll reduce it by 69%. So those are the two targets for us as part of science-based initiative. Then there is a lot which Ultratech who is part of also GCCA. We are trying to do climate leadership or work on the across value chain, and So before GCCA, it was Cement Sustainability Initiative under the WBCSD umbrella, where the work on broad sustainability started, and their focus on carbon was there. And as part of that CSI initiative, the first low carbon technology roadmap also came in, and then the review on performance was also published under CSI. Then now under GCCA, we have different performance standard, and one amongst those is carbon related performance standard. And then as an association also, net zero commitment has been made, where we have said the whole GCCA and its member company will deliver net zero concrete by 2050 or earlier. So raise more in terms of effort across value chain for the sector. And I think this is the last slide for me. This particular slide just showcases what are the broad themes in which companies are working to deliver or to move towards net zero. So when you look at this chart, then moving towards net zero, as a company, we are trying to work on design and construction. So trying to work on value chain so that you are able to influence reduction of your carbon footprint. Then when you look at one level below, it is about, let's say, efficiency in concrete production. So there is so much which you could also do in concrete production stage. So you can increase blending. You can look at maybe better efficiencies of manufacturing concrete, less of electricity consumption. All of those will reduce the whole carbon footprint. Then we also try to save cement and binders, and then also having savings in clinker production. So put together, all of this is going to help us reduce almost like 60% of emission, close to 60% of emissions will come down by broad levers of this. And then the studies which the GCC as a sector has also done and commissioned, similarly IEA also said that carbon capture will help the sector by almost 36% to bring down its intensity level. And beyond that, then you have things like renewable energy and recarbonation. So these are the kind of broad path which GCC has laid out, and then member companies and other cement companies could also pursue the same part towards net zero. I think that was my last slide, and I'll be happy to take questions as part of this session.
Mr. Vishal, wonderful presentation. And your company being Ultratech is #1 in the country, being a big group, such initiative can always be a example for others. One particular thing, science-based target, which you are talking, I personally believe that one wonderful thing which happens is a commitment from the management. Once you declare the targets, it becomes a management commitment. And once it becomes a management commitment, team will automatically do it. They will find out methods, means, how to do, when to do, because management will force them. This is our target, we have to achieve. And once it is a management target, it comes under the performance of individual CEO or individual president or individual plant head or the team member. So this is from top to bottom driven process. And unfortunately, in our country, it is missing. Actually, it is missing. People feel that a cement plant is available and some target values are available from the manufacturer, and we are achieving slightly less than that is enough for us, Malla. So this type of target setting and systematically planning for future, over 20 years, 10 years, then automatically it will give a feeling that yes, it can be achieved. You see, your last slide clearly said that yes, we can achieve something better than this, Mala. And it is really wonderful. And I think this type of system, of course, it is all available in other companies, but not scientific way. Scientific way in the sense, you will not find many companies still do not have GHG emission targets. You can find their production target, you can find their profitability, in all other targets you can find. But GHG emission targets you will not find, because many people still believe that it is going to cost more. And in my opinion, actually, when you see, look in our company, when I was working in Vasodata, it was when we have certified for our platinum journey, Green Co. after 5-6 years, we realized that our cost of production has come down drastically. And rather, we are much better placed than anybody else, in spite of doing so many things for reducing the emissions and other things. So finally, it pays. So therefore, it is good things that everybody should work with a scientific method of target setting and then working on it. Actually. So that is better way that. Thank you very much.
Thank you.
Yeah, I call upon, I think last presentation is there.
Mr. Jaydeep, sir. Yeah.
Yeah, from JK. JK, it is from JK Cement, no? So Mr. Rajkumar Kunda Swami. Eh? He
Yeah.
was supposed to be.
Mr. Jaydeep has joined from JK Muddapur, sir. Yes, sir.
Okay, Mr. Jaydeep.
Am I audible?
Yeah, you are audible, sir. You can just
Yeah,
try
yes.
sharing your screen. We have made you a presenter. Mr. Jaydeep?
Yeah, we are.
Yeah, now it is coming. Yeah.
Yeah, yes. Again, some.
Is it visible?
Yeah, it's visible,
Yes.
sir, but you have
There
to
are
close
two.
the other screen. Yeah, you have to close the other block. Just by clicking on that, you can close
Full
it.
screen.
You can minimize it.
Yeah. That way.
There is one more on the top, sir. Yeah.
Yes. Oh, again, it has come up. No, it's okay.
Is it okay?
Yeah, sir. You can make it full screen and you can go ahead.
Full screen.
Yes, sir. It is fine now. You can go ahead.
Good afternoon, Chairperson, esteemed representative of CII, and all the guests invited here. Myself, Rajan Jha, and my colleague, Mr. Jaydeep Lad. On behalf of JK Cement Muddapur, I would like to thank CII for providing us an opportunity to showcase our energy efficiency best practices on this 18th Green Cementech platform. JK Cement is a flagship company of JK organization established in 1975 under the great leadership of late Sri Yadupati Singhania ji. We are involved in cement business from last 5 decades. Our group grey cement capacity is 16 million ton per annum and white cement capacity is 1.2 million ton per annum. JK Cement Muddapur is having capacity of 2.2 million ton per annum clinkerization and 3.5 million ton per annum finished cement grinding. We are certified with various ISO certification, and we are also a great place to work certified and Greenco gold rated plant. We are having a state-of-the-art technology plant. This is our process flow and major equipment details from mining and crushing to packing plant. Clean and green is only profitable and sustainable. In the same line, we have created national benchmark in energy efficiency and renewable energy category in Greenco rating. During this Greenco journey, we became 1.7 times water positive, and our target is to become 5 times water positive in next 2 financial years. During this Greenco journey, we have increased our renewable energy consumption up to 41%, and in this current financial year, from last 2 months, we are on the verge of 60% renewable energy consumption, and our target is to go with 100% renewable energy by 2030. We have also reduced our GHG emission drastically up to 550 kg CO2 emission per metric ton of cement, and our target is to achieve 500 kg CO2 emission per metric ton of cement. As far as waste management is concerned, we have achieved 18% TSR, and our aspiration is to achieve 50% TSR in coming 4 years. Energy is expensive, efficiency is not. So at JK Cement Muddapur, we focus more on efficiency. We have reduced our specific thermal energy consumption drastically from 705 to 678. In this financial year 21-22, there is a slight increase in our specific thermal energy consumption due to higher consumption of TSR. due to higher consumption of alternate fuel. As you know that by increasing each percentage of TSR, our specific heat consumption is increased by 4 kcal per kg of clinker. In spite of 18% TSR, we could be able to manage our specific thermal energy consumption within 692. This is our specific electrical energy consumption, where you can see a drastic reduction from 84.74 to 63.81. This is our product-wise grinding power, where also you can observe a humongous reduction from 38.4 to 29.52, and you can also observe a reduction in product-wise grinding power. These are few highlights of our plant. We have already achieved national benchmark in green coordinate energy efficiency. We have reduced our GHG emission by 30% in last 3 years, and our target for 2024 is 500 kg CO2 emission. We have already substituted 41% conventional energy by renewable energy, and already mentioned earlier that in this financial year, in last 2 months, our green energy contribution is around 60%, and by 2030, we are going for 100% green energy. Our captive power plant auxiliary consumption is 7%, which is best in the industry. Currently, we are 1.7 times water positive and 10.42 times plastic negative. JK Cement Muddapur is first plant in India to create hot bottom formation in low NOx calciner to mitigate NOx emissions. We are already having a solid and liquid AFR state-of-the-art technology to improve our TSR percentage to achieve our aspiration 50% TSR. When you desire something wholeheartedly, whole universe sets it into motion. JK Cement Muddapur is a standalone plant across the globe which is running without raw mill CF silo with great energy performance. Earlier, our capacity utilization was in the range of 50 to 60%, so we are not going for raw mill CF silo, but nowadays our plant capacity utilization is in the range of 75 to 80%, so we will definitely go for CF silo in next few years. With CF silo, our specific power consumption up to clinkerization will be around 43.2 unit per ton of clinker, which will be globally best. This is just a comparison with CF silo and without CF silo. Things which you cannot measure, you cannot control. So this is just a comparison of our best achieved figure along with national best and global best. In terms of total plant power, our best achieved figure is 63.81, and we are already having a roadmap to achieve 58 unit per ton of cement. Our specific heat consumption is very much closer to national best, even with 100% pet coke and 18% TSR. Now Mr. Jaideep will continue with innovative projects.
Innovation is tougher than creation. There are few innovative thermal saving projects. First one is KSG pyrojet burner to reduce specific heat consumption. In current scenario, fuel price is the major concern to all cement plants in the country. So we have decided to reduce our specific heat consumption by implementing latest technology burner in place of old conventional burner. The problem with old conventional burner is high primary air consumption up to 14% due to high AFR usage, sulfur volatile in burning zone, and due to AFR usage, free lime is marginally higher. We cannot be controlled by flame. We are using latest technology KSG pyrojet burner, which is effectively reduce thermal NOx, primary air, and reduce free lime. By installing this burner, our primary air consumption got reduced from 13% to 8.5%. And we have got thermal savings of 5 kilocalories per kg clinker. For this project, our investment was 90 lakhs and with the payback of 1 year. The next project is feedbox height reduction in riser duct of cyclone. We observed low heat transfer in string 1 and 2 riser of stage 2 cyclone in 8 floor preheater. The height of feed box is higher than the other stages, that is 2.32 meters. The optimum point of feed inlet to riser duct is 1 meter from the cyclone top. So we have decided to reduce the feed box height by 1.32 meters. This increases the heat transfer between hot gases and raw material in each stage before they get separated in cyclones. This resulted in lowering exit gas temperature in preheater systems. By this, we have achieved thermal saving of 2 kilocalories per kg clinker and cost savings of around 41 lakhs per annum. We always convert spark of possibility into flame of achievement. There are some new innovative electrical energy saving projects. First one, raw mill damping height optimization. The problem in operation is high mill main drive load. Because of more bed height, there was low, resulting in low grinding efficiency and less external recirculation. Raw mill is key area to reduce the overall clinkerization power, as raw mill power contributes 1.5 times in clinkerization power. We analyzed this problem and did damping height optimization in raw mill. By this, we have reduced our specific power consumption by 1 unit per ton of material and cost savings of 1.75 crores per annum. The next project is enhancement of TSR percentage and coal mill availability. Coal mill was stripping very frequently due to COI problems. High CO in preheater system during AFR feeding leading to disturbance in kiln operation as well as coal mill operation. Intermittent CO peaks due to release of bulk material whenever 100-liter blaster gets operated. So several modifications carried out, and we have replaced high capacity air blasters with 2 less capacity air blasters, that is 25 liters. And blaster operation logic given in such a way that no material can release in bulk form to prevent CO. Provided one poking arm connected with pneumatic cylinder, and it operates in coordination with air blasters to restrict chute jamming. By these modifications, we were able to increase our AFR feed up to 15 TPH, avoided coal mill tripping due to CO formation, and increased our TSR by 2.5%. The savings achieved due to powers are 14.9 lakhs per annum, savings due to AFR 247.7 lakhs per annum, and total savings of 262.6 lakhs per annum. The next project is troubleshooting of RA-based problem by process optimization. Continuous increase of RA-based causing kiln production loss as well as increase in power consumption. The RA-based value was increasing continuously, resulting decrease of kiln feed and AFR. The frequency of reduction was around 3 to 4 times in a day. As we are consuming variety of AFRs, so there was formation of alkaline chloride in the system, and it promotes formation of dust cake formation on the bags, which deteriorates the bags and leads inefficient operation of baghouse. Modifications made such as modified the cleaning sequence of RA-based cleaning pattern, checked acid dew point, and started maintaining RA-based outlet temperature greater than 180 degrees centigrade in order to avoid acid condensation in the system. Interlocking of preheater water pump given with RA-based outlet temperature, that is 180 greater than 180 degrees centigrade. The air balancing operation has carried out by changing damper positions with kiln feed 450 TPH. With this, we optimize RA-based temperature and cleaning operation to operate our kiln feed 450 TPH continuously and AFR TPH 15 TPH. With this, we achieved savings of 1,342 lakhs per annum on account of power production and TSR loss, achieved savings of 110 lakhs on account of full RA-based bag upgradation. The next project is the Cement Mill 3 productivity improvement by reducing annular gap near separator. In Cement Mill 3 VRM, we were facing high power consumption issue as well as we were not able to get desired TPH. So cross-sectional area reduced by putting skirting inside the mill casing near separator. By this, we have increased velocity in the separator as well as dust loading of separator also increased towards diverting material towards the same. To avoid fines returning to the table, mill resulting the less internal material recirculation load. By this, we were able to increase our PPC feed from 305 to 350 TPH without compromising quality parameters. With this, specific power consumption got reduced by 2 units per ton of cement and savings of 75 lakhs per year. The next project is increase in clinker SO3 to get clinker better strength. We always take challenges as an opportunity. Petcoke is widely used fuel in the cement industry and it is having high sulfur content. Many plants face problems with this high sulfur petcoke, but we have used this petcoke to enhance our cement and clinker strength. So for that, we have carried out several activities such as increased our fuel sulfur content by changing fuel mix, changed our raw mix to easy burning mix, and started running our pyro system in high oxidized condition in order to ensure sulfur absorbed in clinker, and did some burner adjustment to get short and wide flame. By seeing these figures, we can say that we are getting good results in cement and clinker strengths. Also, we have achieved cost savings by cement mill additive increment. Like in PPC, we have increased 5% fly ash addition, and in PSC, we have increased 5% slag. By this, we have annually saved 10.2 crores. The next project is role of clinker factor in power consumption. Over the years, we can see that from 17-18 to 21-22, our overall clinker factor reduced from 75.21 to ever lowest 68.68%. In last financial year, our PPC grinding percentage was more, that is 46%. As we all know that clinker factor plays very important role in reducing total power consumption. And also reducing the clinker factor, we are contributing towards net zero mission. Here are several improvement activities carried out in pre-clinkerization section, and they're mainly to improve raw mill reliability. We have given raw mill feed bypass chute near raw mill rotary feeder. And second, to increase specific air in preheater, we have did preheater fan tipping and to increase AFR feed rate. Also installed mechanical lump temperature in coal mill feeding belt. As per CFD study, we have placed baffle plates in preheater downcomer to reduce pressure drop. And preheater height feed box modified in such a way that to reduce specific heat consumption. In last 4 years, this is the ENCON project summary. In last year, we have given total 34 ENCON projects. In that, 10 projects are nil investment and 24 projects are with investment of 55 lakhs and savings of 302 lakhs. Next, I will pass on to Rajan Jha sir.
Without mission and vision, you cannot accomplish any goal. So this is our roadmap to achieve national or global benchmark. We are already having internal benchmarking system, Kaizen, innovative projects. We are conducting brainstorming session time to time. We are already having internal process audit team, and we are also inviting external audit to assess our system. JK Cement Muddapur always welcome latest technology available in the market. Action speaks louder than words. So this is our action plan to achieve our aspiration 58 unit per ton of cement. We are going to invest around 62.2 crore rupees, and our savings will be rupees 30 crores per annum, and payback period will be 2.1 years. This is our action plan to achieve national benchmark. There are various projects which we are going to implement, like installation of VFD for raw mill fan and coal mill fan. Installation of pre-grinder system in ball mill will definitely help us to reduce our specific electrical energy consumption. Installation of BFD for RABH fan. We are also going to install secondary crusher to reduce the raw mill grinding power. Cement mill 3 classifier upgradation. We are also proposing new CF silo for raw mill storage as mentioned earlier. We are also going to install solar mill to cater preheater lighting load. Coal firing HAG for CM3. We don't only believe in productivity. At the same time, protection of nature is our prime importance. We have increased our TSR percentage from almost nil level to 18%. In FY 21-22, we have replaced around 31,737 metric ton of coal. As mentioned by panelists, that net zero is not an option but a need of the hour. In the same line, we have increased our renewable energy consumption up to 41%, and our aspiration is to go with 100% renewable energy by 2030. In this financial year, in last 2 months, our green energy contribution is around 60%. Recently, we have installed one 5 megawatt solar power plant, and we have invested in so many wind projects off-site. This is our carbon footprint reduction data, where you can see a drastic reduction from 874 to 619, and our aspiration is to achieve 500 kg CO2 emission by 2024. These are few environmental projects which has been already implemented, like atmospheric water generator, light pipe installation to use daylight, liquid AFR feeding system. Recently, we have installed 5 megawatt solar power plant. This is Bima Bamboo plantation. This is few photographs of green development. We have won several awards and accolades. Feathered in our cap is CI National Award, National Leader Award, and VIII A National Energy Conservation Award. At JK Cement Muddapur, sky is the limit. Continues towards grey to green. Thank you.
Mr. Jaydeep, it was wonderful presentation, and I would only request you to apply for the platinum certification. You are only gold certified, and you are doing wonderful job. CII will help you to make your plant platinum certified.
We have already applied for Green Co Platinum, sir.
That's very good. Because I was associated in this journey to some extent, and I know the team there is highly enthusiastic, and they want to do a lot of wonders. And other participants, those who are listening to these presentation, can definitely make use of so many ideas. They can contact directly JK people, and if they have any doubt on a particular implementation, and it will be very useful. I am very much impressed. You see, most of the industry should concentrate on water. Your water 1.5 times water positive is an excellent step, because water will become after 10 years very costly, and it may be that water is not available. So therefore, we have to generate our own water. That is very important. And similarly, your greenhouse gases reduction targets are very good. You can do many more things, and you are doing it, and you can keep doing it. A lot of other informations are available in your slides: renewable energy, and your what I can say is the GHG. I already said waste utilization. Your TSR, you have a target of 50%. You see, look, now it's a wonderful target, and I'm sure you will be able to achieve. It will be an example to industry that such type of target can be achieved. You see, look, if I remember correctly, there are certain plants in the world there they have a TSR up to 80% or 90% actually. So therefore, there is no limit. Only we have to solve our quality issues and other problems and keep increasing it. And that is the key for sustainability. So thank you very much. Thank you very much.
Sir, we have only one question from the delegates. That's addressed to JSW. I will read out, sir, with your permission.
Yeah.
Dr. Majunatha.
I am there, sir. I am there.
Yeah, sir. So how is JSW progressing in hydrogen generation and use in DRI steel making technology and integrating the hydrogen power with cement production?
Yeah, see, hydrogen is a new technology. Everybody is now working on that actually. Mainly, we are also there being in the energy sector. We are working on hydrogen energy. The integration part, everybody is working on that. Innovation is happening. Maybe in 1 year down the line, we can see the light at the end of the tunnel, because both steel as well as cement, they are very energy intensive manufacturing process. So if hydrogen comes into play in helping this industry to neutralize the carbon emissions, it's a very good step. So we are progressing, and also the technologies have to evolve globally so that we can adopt the best technology. We are working towards that.
Thank you, sir. Chairman, sir, if you want to conclude the session, we can do that, sir. We are just 2 minutes away from the next session. Thank you, sir.
Yeah. I would only like to tell that there is no end for improvements, and every company, all the companies should look into what are the areas where they can improve. They can consult CII. And in my opinion, actually, I was having an issue that how to motivate the team. So therefore, we have gone for a certification. Once we have gone for the certification, CII team came to us. They have given a lot of projects. Everybody, the committees were formed, things were changed, and then finally we got the certification. also, we got the platinum also, and then the journey was not ending. Everybody was coming with a new idea, and things were keep changing. Cement industry, in my opinion, is a open industry where a lot of case study and other informations are being shared. So therefore, the most of the companies can really do wonder. They should keep doing it so that we can achieve net zero, and rather at least move in that direction. That's all what I want to say. Thank you.
Thank you, sir. Thank you, Chairman. Thank you, all the speakers, for your valuable time and valuable inputs. We will upload all the presentations once we get that from the speakers. You can join us for the next session. Thank you. With that, we will close this session. Thank you, sir.
Thank you, sir. Thank you. Thank you, CIA, for a wonderful opportunity for all of us. Thank you very much.